Okay, you would like to say that in question 2 that the firefly or the bus exerts a greater force on the firefly. Why? Because the firefly was smashed to bits, right? Yeah. It sounds like it exerts a greater force. But according to Newton's third law, what happened? Okay, the bus strikes. The firefly hits the bus. Body A, firefly. Body B, the bus. So, body A, firefly, exert a force on the bus. Then, according to Newton's third law, the bus should exert an equal and opposite force back on the firefly. But why does the firefly explode into a mess? Because the firefly mass greater.
No, the bus mass greater.
The bus mass greater. Okay, because the bus is a greater mass, while the firefly is a smaller mass. Okay, that's why it's small. It's got smashed up. If instead we have a giant firefly, Jonathan's firefly, that will smash the bus out there. Okay, correct or not? So I don't fall for it and think that that means the force is greater on the firefly. Most people will say that, but that's not correct. Okay, so the key word, how you phrase it, Shahir, is that you have to identify the two bodies. What are the two bodies? One is firefly, one is bus. So you say the firefly exerts a force on the bus. Okay, and then according to Newton's third law, the bus will, Shahir, what are the two keywords?
Opposite equal force.
Okay, an equal and opposite force back on the firefly. Right? So that's how you answer this kind of question. You're using Newton's third law. So you identify the two bodies, firefly and bus. Then say firefly exerts a force on the bus. Then the bus exerts equal and opposite force back on the firefly. Right? Then which one splatters? The fly. Okay? But if you're Jonathan, the bus, because to him fireflies are humongous.
Bigger than the bus.
Bigger than the bus. Yes. Okay, you look at question 3. Question 3. What does it mean? Draw a free body diagram. Draw a free body diagram means simply draw the forces acting on the toy train.
Was it only one?
Ignore the vertical forces.
So there's no push.
Okay, let's say we don't ignore the vertical forces. You tell me, okay, go to the most obvious force. There is the what? The train. So, Shahir, one, what? First one, obvious.
Like the pull force.
Oh, okay. The pull force, where?
From to the right.
Okay, where is it being exerted? The rope, yes. This one, the pulling force. Okay, you want to call it a pull force, not wrong lah. When there's a rope, there's a force exerted on the rope, we give it another name, start with T, tension. Okay, but you call it a pulling force, it's not wrong to say that. It is called a tension. Okay, so there is one force. So Dylan, the other obvious force is what? The weight. Okay, if we are not ignoring the vertical forces, so you can always say that's the weight. Okay, then Shahir, what other forces are there? This is on a rough surface. You read the question and say got frictional force.
Friction.
Friction, right? Where is it acting?
In the opposite direction.
Oh, where will I draw it?
Like
On the?
Like around the wheel.
Around, okay, here, not say around, here, on the two wheels. So friction, right? Okay, so there's a frictional force acting on the wheel. Okay. Then there are two more forces. Shahir, you know what are they? No? You just learn only.
Like normal force.
Where? Let's see whether you make the mistake or didn't.
It's like
Where will you draw it?
say from the
From the wheel. Dylan, correct or not? From the wheel.
Mm-hmm.
Or is it from the weight?
No, I think from the way.
From the weight or from the wheel?
Such hard time.
You last week made a mistake, you should know.
Stop confusing him.
You. Dylan, what's the answer? Where's the normal action force?
From both views.
From both wheels, correct. So from both wheels. Okay, so from both wheels, okay, I lazy write out the whole name. It's normal reaction force. This one is friction.
Easy right now.
You cannot be lazy.
It's so long.
Okay, so you got to label all the force. So normal reaction force is always from where the two bodies are in contact. Okay?
But what happens if it's gravitational pull? Then it'll be the same.
Yes. If let's say you are drawing the force acting on the earth, then you'll be in the center, the weight, correct. Yeah. Okay. Okay. So read part B, think about it.
Exerts a force on the rope, and according to Newton's third law, the rope will exert an equal and opposite force back onto the
Yes. Very good. Okay. So you identify first of all the two bodies. So you say the hand and the rope. Okay. So then you say the hand exerts a force on the rope, and then according to Newton's third law, okay, so similar to the firefly answer, get the hang of it. So that means if the hand is pulling with 100 newtons, that means the rope pull back on the hand with 100 newtons.
Is that how you get tension? Is that how you get tension? Or is that a separate thing?
When you are pulling on the rope, you get tension, right? Then the rope pull back in your hand. Does your hand, in a sense, have tension as well? Yes, because your hand is also being stretched out. Okay? So you get the idea. Now, Shahir, what this guy Dylan was saying just now, Newton's third law can also actually happen when things are not in contact. Okay, so far is okay, the trailer rests on the ground, the car on the ground, all this can. But even this also is an application of Newton's third law. So if let's say you have the ball in the earth, okay? The ball exerts a force on the earth.
Should be the earth exert force, no?
Or rather, rather the earth, the action is the earth exerts a force on the ball, pulling the ball down, right? Then, according to Newton's law, the ball will exert an equal and opposite force back on the earth. So it exerts a force back this way, right? But your earth don't fly towards the ball, unless you're Jonathan, okay? Because the earth is simply too massive, right? Okay, so it doesn't need to be in contact. Also, you have Newton's third law also can be applied. Look at the next part, try to do. Okay, now some calculation. Okay, Shahir, especially you try, see can do. No? Dylan should be able to do unless you have forgotten your work.
I've forgotten everything. Oh,
okay.
my bad. Yo, I'm confusing myself, I swear.
Okay, so they're asking you for frictional force. So you read the question. They already told you the frictional force is given over here as 0.5 Newton per kilogram of the mass of the train. So all you have to do is, well, you don't actually need to write the two lines. So it's just 0.5 times 1.8. That is 0.9 newtons. Okay, 0.9 newtons. So that's your frictional force. Okay, then next one. Calculate the maximum acceleration.
Wait, let me try.
What are the two lines?
F equals MA.
Yes, second line.
F opposite minus F opposite.
Opposing, don't say opposite.
Equals MA.
Okay, we are asking you to find acceleration. Okay, they never give you speed, they give you time, so this is the only way. Now you look at which is the force motion. How much?
The tension force.
Which
like
is?
3.5.
Good. So you write that 3.5. Friction is?
0.9
M is? Mass?
1.8.
Dylan, you got do like that? No?
I did everything but the second line. The F motion minus
So you 3.5 minus 0.9 lah.
equals 1.8, then A. Then I just did it.
Okay, same thing lah. That means you just skip writing that lah. Okay, so Shahir, this is an example of how to use the two lines to solve, right? Okay, do part 1 and 2. Here you got to go back to your previous chapter on kinematics. Okay, use the acceleration formula, V minus U over T. Then calculate distance. How do you think you calculate this? How do you calculate distance? Get distance from where? Draw a speed time graph for part 2. Then you will know.
Do you write this? It's not simply D equals speed times time.
Yes, I
I
did.
think for Jonathan.
It's for him, but even I write that, I'm sure he will. Okay, so just use a formula which you have been using a lot in the previous chapter. V minus U 0 T 3, so V equals 4.2 meter per second. So the next one, calculate the distance. 0 3 seconds, don't use speed times time, draw a graph. Because you'll be wrong. So speed, meter per second, time, seconds. What does the shape of the graph look like? I think you all should know, should be good at this. What? Straight line, curved line, flat line.
At a constant speed.
It should be like from 0 to 3 like a flat line.
Flat ah? Like that ah?
No, like
Increasing speed.
no, like
Constant speed.
from 0 to
What kind of gradient?
Constant.
Constant, right? Like this lah.
Yeah.
Constant gradient, right?
Constant speed, yeah.
0, 3, 4.2. Okay, very good. So, how do you find the distance? From here, very easy.
Oh, area bigger.
Yes, so
4.5 times 4.2 times 3. That is 2.1 times 3.
what is this? 2.1 times 3 is 6.2, 6.3, right?
Yeah.
Okay, so you can see how this question links on to the previous chapter easily. Okay, now read part E
Oh my god,
and think part E is a good question.
speed, right?
Now you say constant speed.
Is it because the force opposing equals force motion?
How about you? What do you think? The idea, you look at the tension. You look at the diagram. Now you're told the friction is 3.5. So most people say, oh, like that, sure, slow down lah. Because the tension so big. Like what you said. But you look at the diagram, notice something.
The
Tension is how much?
3.5.
Also 3.5, right?
So constant speed.
If you say constant speed, another guy will say cannot move. Jonathan will say accelerate until don't go where. Which is totally wrong lah. So Shahir, what do you say?
say like come to rest or something.
Yeah, because you're still not very familiar with Newton's first law. Most people will say you come to rest. but you look at this. The friction is equal to the tension. In other words, you are going back to our 4 boxes. And what is our 4 boxes? The force motion is now equal to the force opposing. The tension is now equal to the friction, right? That means the resultant force is 0, huh? Okay, so this Dylan already said the first box. Then this is the second box. So shall here acceleration is what? 0. Then 2 possibilities. At rest. Just stop like that. Or constant speed. Which one?
Not constant speed.
Yeah. Why is it at constant speed?
Same motion.
It was, yeah, correct. It will carry on in motion. So it will go at constant speed. So you got to watch out for this. This type of question. Very, very, I tell you it will come out. For sure. It's just only what form does it appear in. So you watch out. Don't say, oh, you decelerate. Oh, you come to a stop. Or you will just simply get faster. It's not correct. So frictional force 3.5 newtons.
Yes.
Equal to the tension. Then you write out the 3 boxes.
Yes.
The 4 boxes altogether. Don't just say, oh, like that you go constant speed. So you gotta say everything properly. So first point to say, Dylan, say what?
As the frictional force is equal to the pulling force.
Yeah. As the frictional force is now equal to the pulling force, which is the tension. So this is balance force, right? That's 1 box. Don't skip and just say, oh, like that you will move at constant speed.
Wait, does it matter which order you put resultant
doesn't,
force?
it doesn't.
Or then it will be like resultant
I mean,
force.
of course, go with a systematic order lah.
Okay.
So talk about resultant force next lah.
Resultant force equals 0.
Resultant force is now equal 0.
Yeah, acceleration will be 0.
Okay, that's 3 already. So as a result, shall hear what happens?
You mean constant speed?
The train moves at a constant speed. Okay, according to Newton's first law. You just keep on moving at a constant speed. So
does Newton only have 3 laws?
yes, for all of us is 3 laws. For Jonathan, there's 5. Okay, so this one, box number 1, this is box number 2, this is box number 3, and then this is box number 4. So when you explain things like this. Okay. So far okay. So this question you got all 3 laws in previous chapter question even. So very good. Not that difficult, but can be applied. Okay. Next one, harder. Why do you think it's harder? What's the difference between this diagram and the next one and the previous questions you have done? Look at question 4. What's the difference? Difficulty. Next level of difficulty is something pulling something. Okay, so I put this one, pull this one aside first. Okay, think very logically. So if let's say we have a bus, okay, this is my bus, okay, and it's pulling a trailer which has a boat along it. Okay, so look at this. Okay, you must know a few things about this situation. Okay, certain facts you must know that will help you solve the question. The very first fact that you need to know is this. If I ask you, what's the acceleration of the lorry and the trailer? Okay, what can you say about it? Should it be the same or different? Same. Correct. both will have the same.
Acceleration.
Number one, both have same acceleration. So if the question were to tell you the acceleration of the lorry is 2 meters per second squared, that means the trailer also has acceleration of 2 meters per second squared. Okay? Got it? Can I? Okay, next. Number two. In order to do this kind of question, you must be able to identify the forces acting on 3 different systems. Now, what do I mean by 3 different systems? Okay, first system, forces acting on the lorry. Second system, forces acting on the trailer. Okay, third system, forces acting on the whole thing. Right? Yeah, so you must be able to identify forces. You cannot identify, very hard to do. Probably can't do that. Okay? Okay, so now you think logically, if I just say, draw the forces acting on the lorry. Okay, let's choose this color. Draw forces acting on the lorry. Draw forces acting on the lorry. Okay, just the lorry alone. Okay, go in the most obvious. Try here, start.
Like the normal reaction force.
Okay, you want to see normal reaction force? Can. So here and here. Short form, normal reaction force. Dylan, next.
Weight.
Weight of lorry, yes. Okay, there's only 2 of you, so alternate. Each one must keep answering. It is moving on a rough road. Next.
Like friction.
Friction. Which way? To the right or to the left? Right here?
Like to the right.
To the right. Okay, friction on the wheels. To the right. Okay. Next, Dylan. There's a lot of forces. Which one?
The forward force, like the engine force.
Pointing left or right?
Right.
Left. Good. Okay. Engine force. Huh? Okay, good. Okay, now there's one more. Can you see where's the one more?
Like the pull of the trailer, the tension.
The pull of trailer, the tension. Hey, today, not bad. Quite smart. You can answer all the questions. Pull of the trailer, the tension. Go on, try here. Is there? He's pulling it, right?
I don't have tension.
Yeah, so where is it? Pointing to the left or to the right?
Should the
Left is this way, right is this way. So which way?
right.
To the right, right? Right? Because why? You just think common sense. The trailer is trying to hold the lorry back, right? It pulls onto on the lorry, right? It's making the lorry's life very hard because the lorry has to pull the trailer along. So this tension is acting this way. Is, what do you think? Force motion or force opposing?
Force opposing.
Yes, it's the force opposing. So you see, you can identify all the forces. You think carefully, clearly, no problem. Okay, so you see a whole lot of forces here. But even you see a whole lot of forces here, just this lorry alone, if I ask you to write out the 2 lines, then you will say this Okay, you will say like that. Right, you follow what I teach, you will write this. Then for the force motion, Dylan, what will you write?
The engine.
The force engine, correct. Then the force opposing, what will you write, Shahir? Just the lorry alone,
Like the friction.
Okay. Is it only the friction?
And also tension.
Right? It looks confusing, but you think about it. There's just 2 extra one tension okay? That's why you want to pull something along the way. You want to pull Jonathan, it's harder. Right? You're pulling something along, there's tension, much more difficult. So you write 2 lines, it becomes like that. Okay, You notice something, if anything is going horizontal motion, Shahir, I haven't told you this, you don't care about the normal reaction force, the weight on it, you don't bother. Even though it's there, you don't have to care. Right? It doesn't affect your formula. Okay? Good, can, Okay, now, this was lorry. So this was draw forces acting on lorry. So now let's say I choose green and ask you to draw forces acting on the trailer. Okay, green. Okay. Okay, come, start again. Similar idea. Dylan, start.
Normal reaction force.
Okay, normal reaction force. Next, Shahir. Friction, which way? Left or right?
To the right.
To the right. Yes, friction. Dylan, next.
Tension. There's no tension there. Right?
There's tension. Okay, good. Now, think, which way?
Wait. Is it the same way? Wait, no, because the lorry is.
This is trailer. So when I say draw forces on the trailer, you just concentrate on the trailer. Don't. You can ignore the lorry. So there's a tension, definitely pointing left or right. Think common sense. The tension is the one that's pulling the trailer along, right?
Yeah.
So it definitely has to be pointing to the left, right? If not, how can the trailer move? Okay? Of course, Jonathan will say point the other way lah. He all confused one lah. Okay, so tension is pointing to the left. Okay, good. And then of course there's one more force
Weight.
the weight, which is not consequential lah. Okay, so here is the weight.
Wait, it evens out in the normal reaction force, right? The weight.
What?
It equals out in the normal reaction force.
Okay, so so last week I also told you this Shahir don't know yet. So you look at this the upward forces must equal to the downward force. Okay? So if this weight was directly at the center and these two wheels are exactly the same distance away, okay lah. In other words, like that and let's say I say this is 100 newtons Shahir, each one of these you think is how much?
100.
The down is 100 already.
50.
50 plus 50 must give you 100. Okay? So this is something I told him last week, so he brought it up. I just mentioned it again. Okay, so these are all the forces. So write the two lines here. Tell me the first line is what?
Wait, so but then for the trailer, right? Then shouldn't it also be a forward force since it's also moving?
It is moving, but what is the forward force in this case?
The lorry.
The tension.
Or
The tension is the one pulling it, right? Correct or not? The forward force is the tension. Okay? The lorry has an engine force, which is on the lorry, not on the trailer. So write the two lines. So here, force motion, what is it?
like the engine force.
It's not engine force.
No engine force, no. I'm asking you draw forces acting on a trailer.
Oh,
So it should be tension only. Okay, there's no, the engine force is there, but it's on the lorry. Minus, opposing,
the friction.
only friction, right? Yes. So this one is easier, MA. And then this M, obviously this M is the mass of the trailer. Don't confuse. Okay, so when you, so you must be able to see, draw forces on lorry, draw forces on trailer. Okay, which is which? Okay, then the third system. What is the third system? The third system is this.
The entire thing.
Very good.
Wow.
Hey, how come you so smart today?
I want to go home.
Huh?
We start on doing a lesson today.
You still no lesson today?
You don't know.
Why?
His dad passed away. Then he's taking break for like 4 days.
His dad passed away.
I think so. Yeah.
Oh, I didn't know that.
Never tell you.
No, I didn't know. He didn't tell me. When he passed away, you know.
No, like I think yesterday or like 2 days ago. You just texted in like group chat, like yesterday.
Oh,
Yeah,
no
it's
wonder you have no lesson.
Yeah, it's not having lessons.
Draw the forces acting on the
Entire thing.
entire thing.
But isn't it just everything added together?
Okay, here you gotta be very careful. Okay, what is everything added together? So you look at this. Imagine the whole thing is now one gigantic thing. Lorry and trailer. Okay? One gigantic thing like that. Okay. Identify the forces again.
The weight, the normal reaction force.
Okay, the usual lah.
But it's just tension because it's one big block.
Okay, weight, normal reaction force.
Yeah.
Okay, is there a force engine?
Probably.
Yes, force engine is still there. Is there the friction?
Yeah.
Yes, still here.
No one about tension.
Okay, good question. What about tension? Now you look at this. When you look at these two,
Oh, it equals out, right?
yeah, equals out, correct. Why? This one point this way, this one point that way.
Right?
They are equal, so they cancel out each other, right? So when you look at the whole thing, there is no tension. Okay, it's just simply one big force engine pulling it this way to the left. Okay, and then there's the friction. But of course now the weight will be both the lorry and the trailer.
So is it like the same for this question? So like the tension force is like 0 here.
They cancel out each other, correct. There is, because you are taking the whole system, it becomes 0, yes. But the friction is more than the ones in green and red. Okay? It'll be more because you're talking about both the lorry and the trailer. Okay? And the mass of course is both of them. Right? So you write this again. The force motion will be the force engine minus frictional force on lorry and trailer. Then this one is the mass of lorry and trailer times acceleration.
The acceleration is the same, right?
Correct. Acceleration will be the same. Cannot be one move faster than the other, right?
Wait, so can you just calculate, like if you want to find the acceleration easily, can you just like calculate of one acceleration of one block?
Okay.
Like this question.
Okay, hang on. So I understand what I mean by tree system.
Yeah.
You're able to draw diagram for all three.
Yeah.
So when you want to solve problem, let's say they ask you find acceleration, you decide which way is fastest. Maybe you say, I just I draw the forces acting on the trailer. That will help me find the acceleration fastest. Then you do that. Okay? It depends what they give you. Okay? So now having said that, you look at this question, okay, you try yourself. You look at question 4 and so for question 4, okay, label the two boxes, easier. Box A, box B. Okay, so calculate the acceleration that both blocks move with. Okay, so ask yourself, you're looking at which system? A alone, B alone, or the whole thing?
I looked at B alone. I mean A alone.
You look at A alone.
So you look at like the whole thing.
Look at the whole thing. Look at the whole thing. Okay, look at the whole thing. F equals to MA. Right? Then horizontal force 12 Newton applied. 12 equals to M. M is 6A. So A is 2 meter per second squared. Okay, here got friction. So we don't care.
Friction is
No friction. So we don't care about the friction. This is whole system. Write down whole system. If not, next time you'll be wondering what am I doing. I also don't even know what I'm doing. Okay? Dylan, just now you say you look at A alone. You cannot, no? A alone. You cannot get the answer. Why not? If you look at A alone, and you do this, it is 12 is the pulling. What's the opposing? A alone. There's tension, right?
Yeah.
So there's tension, right? So 12T minus equals to MA, right? You got two unknowns. You cannot do it. But once you find A, you can do it already. So part B. Okay, you all try part B. Part B. Let's look at part B. Calculate the tension in the string on acting between the two boxes. So Dylan, look at A alone. F equals MA. 12 minus T equals MA, right?
Oh, it's just 4. Is it 4? Exactly.
So 12 minus T. A alone, Dylan, what's your mass?
No, mass is 4, right?
4. A is how much? 2.
2. So T equals 8.
So T equals
8. Wait, no, 4.
4.
Yeah.
4 newtons. Right? Okay, so he got 4. Okay, Shahir, your turn. B alone. You look at B alone. Tell me what are the forces acting on B alone.
Tension.
Got tension. Okay, this question easy. Why no friction? So tension, right? Correct. Agree? So, okay, then you F equals MA. Then this is T. There's no oppose, right? So 0 MA. T equals, Shahir, M is how much?
M is like 2.
2. A is?
Also 2.
Then see both of you get the same thing. 4 newtons. Okay? So, just now, okay, maybe a bit confusing. I say, the tension 0. It's not 0, they cancel each other. Because one act that way, one act the other way for the whole system, so they cancel out each other. But there has to be a tension, if not, how to move. Okay? So 4 newtons is the answer. So the trick of all this, when you do this kind of question, is it's not so simple. You identify which system to look at. Whole system, A alone, B alone, and then from there you solve. Like for part B, you can do A or B alone, also can get the same answer. Alright? Now comes the challenge of 5. Okay, this one exam question come up with
But
4.
I drew everything, but I'm pretty sure since you say the challenge of 5 is all wrong.
Well, you probably can do it. You are in good form today. So try 5. Let's check. You're very fast today. Okay, 5A. Start, Dylan. 1 force.
Weight.
Mm.
Then the normal reaction force. That's it, right?
Normal reaction force, 2 of them, right?
Yeah.
Stationary, right?
So there's nothing else.
Nothing else, not moving. That's all. Easy. Okay. Then moving, everything the same. Still got normal reaction force, still got weight.
Force and friction.
Normal reaction force, weight. Okay. What else?
Forward and friction. The force.
Forward force and friction. Okay, very good. See, all correct. Well done.
But the second part, thinking of fun.
Okay, everything correct. Okay, very straightforward. Okay, now. Okay, part C. Part C, part 1. Okay, of course you got to read the question first. Read the question first. Read what it says. So you read the question already. Okay, truck alone. Start, Shahir.
Normal reaction force.
Okay, normal reaction force. What else?
Friction.
Friction. What else?
Like a forward force.
Forward force
Then finally the weight.
and the weight. Okay.
And now we are tension.
Still got tension. Pointing where? Left or right?
It should be opposite direction, so it should be on the left.
Yeah. Okay, tension. Good. Okay, Dylan, your turn. Trailer.
Normal reaction force,
Usual.
then tension to the right,
Mm.
friction to the left, and weight down.
Okay. Okay. You all have no problem drawing the forces and identify. That's a huge thing. You can't do that, then cannot do it. Okay. Now you all try. See whether you can solve not. Right.
How do you figure out the force motion or the forward force?
Okay. You try and think yourself first. Okay. Think which system you want to look at. Truck alone or trailer alone. Decide which one you want to look at. One is easier than the other. If you look at part 2, how do you calculate the tension? You can look at the trailer or the truck. Which is easier? Trailer. Look at trailer alone. Okay, so you look at trailer alone. Trailer alone. F equals MA. Trailer alone. What's the force motion, Dylan?
I don't know.
What is pulling the truck or the trailer?
The tension.
The tension. So
Oh my god.
so what's the opposing?
-5. Oh!
Which is the friction, right?
Oh, I forgot that the tension will equal to the. Okay. Oh my god.
So T minus 5 equals to 1000 times 0.1.
100, then you bring over 5.
This is 105.
Oh my god.
Then okay, stop using God's name in vain.
Okay.
Okay, next. Okay, both of you do the next part. You are getting the hang of it already. Okay, you all get a 655. Okay. Okay, Dylan, start with you. You look at truck, right?
Yeah.
Okay, truck alone. Shahir copy down the alternative way also. So at least you can do by 2 ways.
I just did it in like 2 lines.
Yeah, 2 lines. Okay,
F
F equals
minus-
MA. So very quick, what is it?
50 minus 105 equal 5,000 times 0.1.
What's the force motion?
Unknown.
Which is what? Force engine, right?
Yeah, minus the reflection, which is 50.
Friction and
The tension.
you should write like that. You don't skip too many steps. Next time you will forget already how you do. Okay, so force engine minus friction is how much?
50.
Tension is
105.
105. Okay. What's the mass?
5,000
5,000.
times 0.1.
A 0.1. Okay, so from here, work everything out. 655, right?
Mm-hmm.
Okay, that's truck alone.
Yeah.
Can make sense, Okay, next will be Shahir. Your turn will be to look at the whole system. So your whole system, what's the force motion?
F engine.
Okay, then
Then it should be minus the frictional force between the trailer and the truck.
both trailer and truck.
Both in trailer.
Both trailer and truck. Both trailer and truck. Do we have to add in the tension?
No, it cancel out.
Yeah, it cancel out. Not 0, but it cancel out. Okay.
Oh,
And then here you gotta be careful. Dylan, you gotta watch out. He do this one. He can do one, but sometimes you forget that there's two friction because trailer and truck. Shahir, what's the both friction is how much?
The 55.
50 plus 5, right?
Yeah.
Okay, 50 plus 5. That's one thing. Then the next thing, your mass also you gotta be careful. Because the mass is
Yeah, total mass of the
how
trailer.
much is it?
Like 6,000.
5,000 plus
1,000.
1,000. So here is substitution lah. The mistake will come if you forgot one of them lah. The trailer or the truck.
How we do this?
Both ways also possible. So from here, you work everything out. You will get 655 newtons. Okay. So this is definitely harder than what you've done before, but since we build up over a series of questions, so you see that actually it's not that bad. Right? So the whole idea to solve this kind of question, you must be able to see what's acting on the truck, the trailer, the whole system. Okay? And draw the forces. You cannot draw the forces, then don't say you cannot do it. Right?